Thank you, ma'am.
Okay, let's get going. Also, by the way, please keep your microphone on mute unless you are talking or unless I ask you to please unmute and answer a question. It's just so that we can keep everything calm and quiet, just like we would in a normal classroom. Right, so if you missed any of our previous lessons, in this particular series of lessons on trigonometry, you can access all the recordings on our website. Okay, so on Tuesday, today's Thursday, on Tuesday, we started looking at trig on the Cartesian plane, and we started talking about the 180-degree rule and 360-degree rule and the cast diagram. So if you miss those lessons, you will find them on our website, and you'll be able to watch them from there to catch up on what you've missed. Also, all our previous quizzes are available on the website, so you can access them as well. If you do the quiz, you get your results straight away, so you don't even have to wait. You'll do the quiz and you get your results, and you know how you are progressing. Courtney, welcome to you as well, and to anyone else who is here this evening for the first time. Right, so let's get to it. And I think what we are going to do this evening is just start off with this little warm-up exercise to practice our 360 and our 180-degree rule. Now, if you do have an answer, let me just remind you to put it in the chat. And I'm going to start with this first question. Maybe just a reminder, over here we've got the Cartesian plane or the cast diagram, all stations to Cape Town, which reminds us where the different trig ratios are positive. So in the first quadrant, all trig ratios are positive. In the second quadrant, only sine is positive. In the third quadrant, tan is positive. And in the fourth quadrant, cos is positive. We can name each of these quadrants according to the angle and how we define the angle. So in this first quadrant, it's theta. The second quadrant is 180 minus theta. Third quadrant is 180 plus theta. And fourth quadrant is 360 minus theta. So if you want to know more about that, go onto our website and watch the previous lesson, and you'll be able to see what we did on Tuesday when we talked about the different quadrants. Okay, so let's start here with question A. What is sine of 180 plus theta? So I'm going to do the first one just to get us going. Sine of 180 plus, this 180 plus indicate that it's in the third quadrant. And the third quadrant, sine in the third quadrant, if we look at our cast diagram, sine in the third quadrant is negative. So we are going to simplify that to negative sine theta. Okay, give a thumbs up in the chat if you are happy with that. Please put a thumbs up in the chat so that I can see that you're happy. Great, Benita, Valerie, awesome. Great, so we're off to a good start. Right, let's do B, and please put your answer in the chat. For theta, you can just write theta. You don't have to try and make the symbol. So sine 180 minus theta, what would we reduce that to? Okay, so we already have some answers coming in. Sine theta, I agree with that. This quadrant is the 180 minus quadrant. It is the second quadrant. And sine in that quadrant is positive. So we can just write it without the 180 minus and just write it as sine theta. Wonderful. Let's go on to question C. cos of 180 minus theta? Cos of 180 minus theta. Please also put your question in the chat. If there is something you're wondering about, just put it in the chat. Okay, so 180 minus theta, that is the second quadrant. Cos in the second quadrant is negative, so we make it negative cos theta. Well done. I see a lot of people putting that in the chat. So remember, we say whether it's positive or negative in that particular quadrant using our cos diagram, and then the 360 or the 180 falls away. Okay, let's do question D. Cos of 360 minus theta. What quadrant is 360 minus theta? You can look over here. It is in the fourth quadrant. Cos in the fourth quadrant is positive. So that will just reduce to cos theta. Yes, cos theta, it is positive because cos in the fourth quadrant is positive. Cos in the fourth quadrant is positive. Okay. Okay, let's go on to question E. Tan of 360 minus theta. 360 minus theta is the fourth quadrant, and I see lots of answers coming in. Well done, guys. Please, everybody, I encourage you to participate and to put your answers in the chat. There we go. We've got minus tan theta. Okay. Yes, Courtney, this is pure maths. Okay, and then if we've got tan 180 plus theta, 180 plus theta, and this is always your thought process, okay? What quadrant am I in? This is the third quadrant. So tan in the third quadrant is negative. Sorry, I'm talking nonsense. It's positive. Well done. Everyone got that one. Tan theta. Okay. A few more to go. We are warming up. Just like you would for a race, you warm up. So we got G over here. Let's see. These are all being squared. Okay, so just a note on when we square a trig ratio. And I'm going to write it in the corner over here. Squaring a trig ratio. And please make a note of it if you are not sure how to do this. So if I have sine squared theta, that is the same as sine theta squared. Okay, so whenever I'm squaring a trig ratio, it will be positive. Yes, that is right. A square, can you see, is never negative. That is a very good observation. Musa, just a note, we actually started with trig last week already, but like I said, please go and watch those recordings of those lessons that are available on our website. Okay, back to our question, cos squared 180 plus theta. Cos squared 180 plus theta is going to be, cos in the third quadrant is negative. But because we are squaring it, we are going to end up with positive cos squared theta. Okay, and then H, tan squared of 180 minus theta. Let's try that one again as well. So 180 minus theta is the second quadrant. So tan in the second quadrant is negative, but we are going to square it. And that gives me tan squared theta. Well done, Panita. everyone, make sure that you have a good grasp of this whole thing with squaring, because when you square a trig ratio, it is always positive. So even if it's incorrect in the quadrant, it will always be positive. For the Sunday, you must get it into the correct quadrant. That is very important. Okay. So the important part is that you do the reduction in the right quadrant. Okay. Last one, question I. Okay, let's think carefully here. Minus sine squared 360 minus theta. So let's do the sine theta first. So sine in the fourth quadrant is negative. So negative sine theta. And we're going to square that. Okay, so use your brackets wisely so that you don't make a mistake. This minus is outside the bracket. So negative sine theta squared is going to be sine squared theta. But because of that minus in front of it, it will now end up being negative sine squared theta. So when we square it, it's always positive. But because of the negative in front of it, it will be negative. Okay, well done, everybody. I think we had a good warm up there with our course diagram and our quadrants. And let's carry on now to looking at negative angles and angles greater than 360 degrees. So, negative angles. Negative angles just mean that you are rotating in the opposite direction. You are rotating clockwise through the Cartesian plane. So if you are looking at a negative angle, you're actually looking at the fourth quadrant. Okay, and I'm gonna use our Cartesian plane over here. And I'm just going to erase this little star here. But if I'm rotating in the negative direction, I'm not going this way around in the anti-clockwise direction, which is what we normally do when we are doing trig. We are rotating in the opposite direction. So we're actually rotating in this direction when we are doing negative angles. So the negative is just there to show that it is a different direction, that we are rotating in the clockwise direction. So if that happens, I will land up in this quadrant over here. Let me just position my little line here in the right place. Sorry, I'm just going to erase it and do it again. Over here. Oh, there we go. Got it. Okay, so negative theta is in fact over here in the fourth quadrant. Okay, so wherever you see negative theta is in fact in the fourth quadrant. So if we know that, we can apply our course diagram, our all stations to Cape Town, to know if the trig ratio is positive or negative. Okay, so in the fourth quadrant, sine is always negative. Cos of a negative angle, which is the fourth quadrant, cos is always positive. And tan of a negative angle, which is the fourth quadrant, will be negative. Okay, so note these down on your page because we are going to use it, and make sure that you understand that part about the negative angle just actually being in the fourth quadrant. Right, can you see that? Just write in the chat for me which part you are struggling to understand, then I can see if I can go over it again. Is it the negative angles or is it the course diagram? Okay, so that's a negative angle, and that's how we reduce it. Can you see, I just need you to be a bit more specific, because we've done a few questions now, and I'm not sure which answer you're referring to. Ms. Nicole, could you maybe just assist Kanyusile in the private chat, please?
Will do.
Okay, Rihad. Please rephrase the part why it's negative in the fourth quadrant. How do we find out it's in the fourth quadrant? Okay, so Rihad, like I said, when we are working with a negative angle, we are rotating in the opposite direction. We are rotating in the clockwise direction. So normally we are rotating this way around. If you just watch the screen, so that is anti-clockwise. But when we are doing negative angles, it just means that we are rotating in the clockwise direction from 0 degrees. So that's why I've drawn the angle, the negative angle, in the fourth quadrant. It's all about the direction of the notation. Okay, so that is the part that you just need to be clear on. That a negative angle just means that you are moving in the clockwise direction with your angle. And that's why you end up in the fourth quadrant. And if you're in the fourth quadrant, using your all stations to Cape Town or your CAS diagram, like the one I've drawn over here, then you know that cos is positive in the fourth quadrant, sine is negative in the fourth quadrant, and tan is negative in the fourth quadrant. Okay, great. Glad that is, you're very welcome, Riyadh. Okay. Angles greater than 360 degrees. Okay, so angles greater than 360 degrees. For that, we just normally look at where we are. Sorry, I'm just going to fix this quickly. Okay, so angles greater than 360 degrees, that just means that we have rotated through 360 degrees and we are now, so watch on the screen how the rotation works. So it goes like this. And if you go past 360, then you end up in the first quadrant. Okay. Okay, Ms. Nicole, could you maybe just assist those learners with muting? Please keep your microphone on mute so that you don't disturb the other learners in the lesson. Okay, see, Temba, you have your hand up. Let's hear.
Ma'am, I wanted to ask for negative angles. Let's say if you get negative sine 80, is it still going to be negative sine, or is it going to change to positive sine, even though you got an 80?
Just give me that again. Negative.
Ma'am, let's say let's say you got sine negative 80, like sine brackets negative 80. Would that be become a positive sign because it's in the first quadrant, or it's still going to be like
that? Okay. So
sorry,
negative. Sorry. So negative 80 means that you've rotated in the clockwise direction and you are in the fourth quadrant. So sine will change to negative sine 80. Yeah, because all negative angles are actually in the fourth quadrant. Yeah.
So it will only change to sine will only change to a positive if it's like sine negative 360 or sine negative 180 or sine negative 270.
Yeah. So with those, yeah. So if you just think about the rotation and into which quadrant, so you're just moving the other way around. So then you can just still use your CAS diagram to know where the trig ratio is positive or negative, even though the angle is negative. It's just going the other way.
Thank you very much.
Sure. See you, Temba. You have your hand up. Oh, sorry, that was September. Thanks, September. Okay. So when we have angles greater than 360 degrees, we are actually just rotating past. Remember, because angles are all about rotation. So we're just rotating past 360 degrees into the first quadrant. And then sine in the first quadrant is positive, cos is positive, and tan is positive. Okay, but I've done enough talking. I want you to now try and do this question where we are going to put all our knowledge together of negative angles and reduction formula. And I've put this little picture here because this is, again, it's a bit of a warm-up for what we are doing. Okay. So I'm going to give you 2 minutes to try it on your own first, and then we'll go over it. Udain, I'm just going to wait a minute while everyone is thinking, and then I'll give you a chance to ask your question. Okay, just 1 more minute to give everyone a chance to just think their way through this problem. Okay, Udain, as soon as I think everyone's done, then I'll give you a chance to try that question.
Excuse me, ma'am, I'm sorry to disturb you.
Yes.
So whenever they say sine 360 plus theta, they're basically saying you're going back to the first quadrant.
Yes, that's
Okay,
right.
thank you. Thank you very much.
Okay, I think everyone's had a chance to have a look. Udain, you've put your hand down. I was going to give you a chance to answer this question. There we go. Udain, go for it. Is your mic working, Udain?
Yeah, ma'am, I was saying that since here we have cos 360 plus x multiplied by sine 360 minus x divided by cos negative x sine 360 plus x, right? Cos 360 plus x is in quadrant 4 where cos is positive. So I think that one will change to cos x. And then sine 360 minus x is in quadrant 4 also where sine is negative. And then I think it will also change to negative sine x. And then cos negative x is in quadrant 4 where cos is positive. That one will change to cos x. And sine 360 plus x is in quadrant 4 where sine is negative. So if we like reduce everything and then we divide all, I think we'll get -1.
Okay. There's just one thing you have to be careful of. This is 360 plus x and 360 plus x. Okay, so that is actually in quadrant 1. So both cos and sine in quadrant 1 are positive. Okay, be careful when you read it that you don't misread it as a minus. Okay, so this one over here is 360 minus, but the other two are 360 plus. So cos 360 plus, we can reduce that to cos x. That's actually the first quadrant. Sine 360 minus, That is the fourth quadrant, and you're right, that's negative sine x, because sine in the fourth quadrant is negative. And then sine of 360 plus is also in the first quadrant. So that gives me cos will cancel with itself, and negative sine will cancel with sine, and you'll get -1. Good. I see a few people in the chat. Guys, please remember to put your answers in the chat. Wonderful. Lots of -1s here. Great. Okay. So that was the warm-up. Let's try something a little bit harder. Again, I'm going to give you 2 minutes to do this one, and put your answer in the chat as soon as you're ready. I prefer to use the brackets so that I don't get confused between multiplication and subtracting. So for instance, if I hadn't put the bracket and I make it cos x minus sine x, that might look different to what this, yeah. So it's just to make sure there's no confusion about what operation we're doing. Okay, please mute everybody. Yeah, sorry.
Ma'am, can I ask a question?
September, I'm just going to give everyone a moment to quickly work this out, and
Okay.
then I'll give you
No,
a
I was
chance.
saying, I was asking, can I ask a question?
Oh, okay, yeah.
So okay, I'm confused. So for the second quadrant is 90 plus theta, and the third quadrant is 180 plus theta. Or is it like something else? Did you hear me properly? Should I repeat myself?
So the first quadrant for now, we're just working with theta. Okay, we haven't done cofunctions yet. That's going to be next. So you can just work with theta in the first quadrant. Second quadrant, I'm going to scroll up for a second just to show you that. Maybe you want to take that down. So it's theta, 180 minus theta, 180 plus theta, and 360 minus theta.
Okay, thank you very much.
Okay. Okay, yes, guys, just a reminder, like Ms. Nicole is saying, please type your answers in the chat and put your hand up if you have a question. For the rest of the time, please keep on mute and do not disturb the other people in the class, please. Right, Tilia, if you're on your phone, you can also Zoom it on your phone. But I have zoomed it now a little bit. Hopefully that's better. Okay, Sihle, I'm going to go through the question again now, and then hopefully just listen carefully, and hopefully you'll be able to understand why cos is positive when it is cos negative x. Okay, remember negative angles are in the fourth quadrant. Cos in the fourth quadrant is positive. Right, I see quite a few answers coming in. I'm going to do this one. And if anything is still unclear, just have a listen, and hopefully it will clear up your questions. Okay, sine of negative theta. So like I've explained today, as the lesson started, negative angles are in the fourth quadrant. So we apply the fourth quadrant where cos is positive, sine is negative, tan is negative. So this will be negative sine theta. I put brackets around everything. I prefer brackets around everything so that you don't confuse the operations and change the sum from multiplication to minus, etc. Tan of 180 plus theta, tan in the third quadrant is negative, so it's negative tan theta. 180 minus theta, that is the second quadrant. So cos in the second quadrant is negative cos theta. Then sine of 180 minus theta. 180 minus theta is the second quadrant. Sine in the second quadrant is positive, so it reduces to sine theta. And then tan of 360 minus theta. Tan is negative in the fourth quadrant. Sorry, yes, tan is positive. You guys are quite right. Yes, tan is positive in the third quadrant. And then cos of negative theta is in the fourth quadrant. Cos is positive in the fourth quadrant. Tipiso, it was just a little mistake. Tan in the third quadrant is positive, so it's positive tan theta. I've corrected it over here. Okay, now we can cancel out. We can take the sine theta with the negative sine theta, tan theta with negative tan theta, cos theta with negative cos theta. Okay, a negative times a negative at the top will give me a positive, but there's a negative at the bottom, so our final answer is going to be -1. Yeah, just check the correction. Tan of 180 plus theta, 180 plus is the third quadrant, and tan is positive there. So, yeah, there we go. Okay, well done to everyone who got -1 and got that one right. Okay, let's move on to our cofunction rule. Okay, so when do we apply the cofunction rule? Cofunctions come into play when we have complementary angles and we have sine and cos. Okay, so if you read here highlighted in blue, two functions are called cofunctions if they are equal on complementary angles, angles that add up to 90 degrees. So I want you to quickly get out your calculator, and on your calculator we're just going to do a quick investigation. Cos, I want you to put into your calculator cos of 40 and sine of 50, and then put in and see what answer you get, and put in cos of 60, sine of 30. And let's do one more, cos 45, tan 45. Ach, not tan 45, sine 45. Okay, so just put those into your calculator and see what you get. Okay, so Dane says the pairs are equal to each other. That's right. Okay, so if you're using your calculator correctly, you should start seeing that the answers for these pairs are the same. Yes, Kanyesile, they are equal, they are the same. And the reason that they are the same is because the angles, look at the angles, 40 and 50, that gives me 90 degrees. 60 and 30, 60 and 30, that also adds up to 90 degrees. 45 and 45, that also adds up to 90 degrees. So when the angles are complementary angles add up to 90 degrees, then the two functions are equal. Okay. So if you want to, you can write down this little note here. But basically what the 90-degree rule says, or the cofunctions and the 90-degree rule, we are talking about the same thing. Okay, so if you remember from your grade 11 trig, the cofunction rule and the 90-degree rule, that is the same thing. Okay, so how does this work? In this quadrant, we have 90 minus theta. Okay, now remember we also said that it is theta. But when you see 90 minus theta, then you must know that it is in the first quadrant. 90 plus theta is in the second quadrant. 270 minus theta is the third quadrant, and the fourth quadrant is 270 plus theta. The cofunction rule only comes into play when you are working with complementary angles, okay? And what happens when we do our cofunction rule? Sine changes to cos, and cos changes to sine. That is what our cofunction rule says. Sine changes to cos, and cos changes to sine. Why? Because for complementary angles, they are the same. Okay. We do still have to do our quiz this evening, so I'm just going to do this one example, and then it is going to be time to start our quiz. But let's have a look so long over here. So sine 90 minus theta. So immediately when you see that, you must know that we are now working with the cofunction rule. And that means sine must change to cos. 90 minus is the first quadrant, so it is positive. Okay, sine theta is sine theta. We leave it like that. And cos theta is cos theta. We leave it like that. Okay, now listen carefully. Here we have 90 plus theta. 90 plus theta, we said, is in the second quadrant. So cos in the second quadrant is negative, but cos must also change to sine in the second quadrant. And what we've got left is minus 1. Cos cancels with cos, sine with sine, but it's a negative, so it's negative 1. Right, Siyatemba, you get a chance to ask one more question.
I'm so sorry for asking so many questions this evening. I just want to, I'm just a bit confused. Please explain to me again, why do you change cos 90 plus theta to negative sine theta?
That is the 90-degree rule that I explained over here. When we are in the 90 minus quadrant, 90 minus or 90 plus, because now we are working with complementary angles. And with complementary angles, sine changes to cos, cos changes to sine. It's a rule in trigonometry. Okay, so it's something that you just have to apply. But it basically comes from, you did this little investigation with your calculator, and you saw that they are basically the same if the angles are complementary. So We can change sine to cos and cos to sine if we are working in the 90 minus theta quadrant and the 90 plus theta quadrant. Okay, so this, if we start again and we go sine 90 minus theta, okay, so we are working with a complementary angle. We must apply the 90-degree rule, then cos changes to sine. So cos, that will reduce to cos theta. Sine theta stays as is, cos theta stays as is. Now, when you are working with the 90-degree rule and you have cos 90 plus theta, cos 90 plus, 90 plus is in the second quadrant. It's over here. So cos is negative in the second quadrant. So that's why we make it negative, but cos also needs to change to sine because we are doing the 90-degree rule here. So negative sine theta. Okay. Right. I've re-explained that. I hope that is clear now. Let me know. We are going to pause there before, I'm not going to do much more this evening just because we still have to do our quiz. There's time for one last question. Kanyesile, you can go.
I'm sorry, ma'am, for taking you back. Like the first questions that we did, the last one, question I still don't get why we get a negative sine squared theta. I'm still confused about that.
Sorry, where did we do that?
It's the first questions.
Oh, over here.
Your warm-up ones.
Oh, the warm-up. Oh.
Yes, ma'am.
So which one here? The
Question I.
Okay, so question I. Okay, let's go over here. So you see that it is 360 minus. So that is the fourth quadrant. Sine is in the fourth quadrant is negative. Okay, can you see there? You understand that? Sine
Yes,
in the fourth quadrant is negative.
Yes, ma'am.
But because we are squaring it, so that's why I wrote here. Okay, so there's my negative that comes from the question. And from the reduction, it's negative sine theta. And we're squaring it. So that will make it positive. But it still has that minus in front. So my final answer will be minus sine squared theta. If it didn't have that minus in front, we would still leave it as positive because we're squaring it.
So, ma'am, for this type of question, our rule or idea that sine squared or cos squared or tan squared cannot be negative doesn't apply.
No, it will apply if there's a negative in front, like we had in that question. Okay, so this question was different because it had a negative in front. But because when we reduce it, because it's in the fourth quadrant, it's negative, we square it. But because it has a negative in front of it, that's why it ends up negative. So we can't say it's always going to be like that. It depends on what the question asks. But if you're squaring a negative ratio like we did here with the negative sine theta, then it becomes positive. Okay, so it will just depend on what the question asks. But yeah, squaring a trig ratio makes it positive.
Ma'am, I have a question.
Thank you, ma'am.
Okay. I'm just going to deal with a question in the chat quickly. Musa. Okay, so Letabo, no, there is no second lesson on a Thursday anymore. Is it necessary to put the brackets when reducing? No, it's not necessary, but it is good practice so that you don't confuse your operations. Okay, anyone else?
Ma'am, the angles will always add up to 180 and 360, right?
Yeah, or 290.
290. Okay.
90 degrees.
Oh, 90 degrees. Oh.
Yeah. Okay. Michelle, we're going to check that answer on Tuesday. Right, thanks everybody. That is all we have time for today. We do have to start our quiz. And I just want to say have a really good Easter weekend. No, there are no more advanced classes. Well done. Right,
sorry,
thanks
ma'am.
everybody. And remember, you can now go do your quiz.
Ma'am, where's the
Um,
quiz?
The
I'm
quiz
gonna
is